Jay here, or you may know me as the Astro 30, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Today we're going to be looking at a fundamental of electronics that everyone should know as a first thing, and that's how to read resistor values from the color codes. I've got a rather small resistor color code chart here, which is the best one I could find. It's actually on the back of a packet of resistors I bought from J-Car, handily. So when I go to do some demonstrations of reading real resistors, I'll insert a graphic of a better color code chart so it's easier to follow. This color code chart is for both the 4-band resistors and the 5-band resistors. I will be focusing for just now on the 4-band resistor, and I will explain what each of the bands are and what they mean. But first we're going to look at what the color codes are. So on a resistor we have digits bands and also a multiplier band. And the number that's represented by the color is different for both. So starting with the digits band, we'll notice there's a bunch of colors down here. It goes black, brown, red, orange, yellow, green, blue, purple, grey and white in that order. And that goes from 0 to 9 respectively for the digits. However, the multiplier, which is over here, it goes 1 for black, 10 for brown, red for 100, orange is 1,000, yellow is 10,000, green is 100,000, and blue is 1,000,000. We also have a gold, which is 0.1, and I'll explain this in just a moment, and a silver, which is 0.01. So let me get a piece of paper out and I'll draw a little diagram. So let's look at our bands on a 4-band resistor. So I'm just going to draw a rather large square or rectangle. So that's our resistor body with its 2 legs. This is the 1st band, 2nd band, 3rd band, and finally our 4th band. Now you'll notice, especially on real physical resistors, there's a bigger gap here between the 3rd and the 4th band than there are between these other 3. That denotes which way round you orient the resistor to read it. So this outer band here, which is further away, is the tolerance band. I'll explain the tolerances a little bit more in just a moment. So that's the tolerance band. The tolerance just tells you how much percentage out, either way, plus minus, the measured resistance value will be from what the red value is. That's all that's for. So this band over here is our first digit, so digit number 1. This second band here is digit number 2. And the 3rd band is the multiplier, or number of zeros. Now, for a start, if this band here is a black, which means 0, then that means the number of zeros is going to be 0. So just keep that in mind. So say for a real world example, we've got some colors here, and the first color is going to be brown. Okay, and the second color is going to be, well, in this example, a black. And for the number of zeros, we have a red. So using the color code chart, which I've actually inserted off to the right here, what are our values? Well, brown is 1, black is 0, and for the number of zeros, red is going to be 2. Alright, so when we read the value, it's going to be 1, 0 with 2 zeros. So we end up with 1000, which is 1000 ohms. So if you divide that number now by 1000, that'll give you kiloohms. So in this case, it's 1K. Pretty simple. Talking about the multiplier or number of zeros, we had colours from black to blue, which is 0 up to 1,000,000. If, for example, we now have a gold or a silver colour as the multiplier, So say that this was no longer red and this was, say, a gold. Well, that's going to be multiplied by 0.1 or divide by 10. So if our first two values are 1 and 0, then basically to multiply by 0.1, we move our decimal point from the right hand side back 1 and we get 1. So in this case it'd be 1 ohm. If, however, this was now a silver, then this is now going to be multiplied by 0.01 or divide by 100. So that would mean that we take our value of 1, 0, move the decimal point from the right hand side back to decimal places, we now have 0.1 or 0.1 ohms. And that's how easy it is to read these resistor color codes. It's not that difficult. However, let's look at our 5-band resistor. So, like the 4-band, we have the first 3 bands here, but we now have an extra 4th band. And there's still a gap here between the 4 bands and the outer band tolerance. On some of the 1% metal film resistors, such as quarter watt, half watt, etc., the body of the resistors is coloured a bluish colour, so it can make discerning what these actual colours are really difficult because they tend to blend in. So a strong light source and a magnifying glass to work out the colours is advised. Now the difference between the 4-band and the 5-band is, well, one, we've got 5 bands, but the 3rd band is now a 3rd digit, where the 4th band now becomes our number of zeros or multiplier. So for example, let's say digit 1 was a brown, digit 2 was a black, digit 3 was also a black, and for the number of zeros we have a brown. Well, what's that value going to be? Well, using the color code chart, we've got 1 for the first digit, 0 for the second digit, 0 for the third digit, and 1 for the number of zeros. What does that equal? 1000 ohms, or 1K. Pretty simple, isn't it? A child of 4 could do this. That's why they employ me. So now let's look at our final band. On the 4-band resistor it's the 4th band, on the 5-band it's the 5th, which is the tolerance. Now, to work out the value of resistance with these colours here, the tolerance isn't really necessary to calculating that. All that tolerance is, as I've said, is the percentage that the resistance value when measured is going to be plus minus out from what the actual colours say they are. So it's the tolerance of the component. But with the tolerances, we've only got 4 colours. So on the right hand side, looking at the chart there, we've got a brown for 1%, a red for 2%, gold for 5%, and a silver for 10%. So in our example, I'll just extend this over to here. If this final band over here, say, was a red, well then that means this resistor, the tolerance of it is 2%. If it was, say, gold, which a lot of them are, then it's 5%. And with the metal film resistors in 5-band, most of them are 1% or brown. and that's basically all the tolerance is for. So let's now look at some real resistors and using the color code chart, see if you can work out what the resistance value is from their colors. Let's go. So in my hand here I have our first example. It's a 1 watt resistor, and off to the right there we've got a clearer color code chart to help you out. The colors may not work out too well on the camera to be discernible, so I'll read them out to you as if you were actually reading them. So in this example we've got a resistor with red, red and brown, ignoring the tolerance. So what resistance value is that? That's right, if you guessed 220 ohm, gold star. Let's move on to our next example. Here's our next example, and it is yellow, purple, brown. If you guessed 470 ohms, gold star. So here's our next example, which is brown, black, black. Using the color code chart off to the right, what value have we got? If you guessed 10 ohms, you are correct. Here's our final example for the 4-band color codes. We've got red, red, red. So, from the color code chart off to the right, what is our value? Well, if you guessed 2200 ohms, or 2.2K, you are absolutely correct. See how easy it is? Now let's look at some 5-band examples. Now, as I say with these blue-bodied resistors, they may be very difficult to work out the band's colours, but I will tell you what they are. We've got a brown, a black and a black for the digits, and for the multiplier we've got a silver. So using the color code chart off to the right, what is the value of this resistor? If you said 1 ohm, very, very good. You're doing very well. Let's look at another example. So here's our next 5-band example. The colors are brown, red and black for the 3 digits, and the multiplier is black. So using the color code chart off to the right, what is our value? If you said 120 ohms, you're exactly correct. So that's how you read the color code bands on a resistor to work out its value. And I hope you found this video informative and enjoyable. If you did, please go down below and comment, subscribe and like if you haven't done so already. And as always, this is the Astro 30 saying see ya, have a great day.